This section is on the Wilcoxon signed rank test. This is a non-parametric test used for hypothesis testing with two medians. First, we verify that the samples are random and dependent. Then we calculate the differences by taking x minus y. And we eliminate any differences that equal 0. Next, we take the absolute value of the differences. Then we sort these absolute values in order from smallest to largest. Then we rank the data, and ties are handled by finding the mean or average of the ranks for the tied values. Then we apply the original sign of the difference to the rank to get the signed rank. Next, we state the claim. The options for the null and alternative hypotheses are listed here. We determine if the test is left, right, or two-tailed. Identify the level of significance. N is equal to the number of non-zero differences. We find the critical value. Next, we calculate the absolute value of the sum of the positive signed ranks, and this is t plus. T minus is the absolute value of the sum of the negative signed ranks. Then we calculate the test statistic t. If the test is two-tailed, t is equal to the smaller of t plus and t minus. If the test is left-tailed, t is equal to t plus. If the test is right-tailed, t is equal to t minus. Then we compare t with the critical value. If t is less than the critical value, we reject the null hypothesis. If t is greater than or equal to the critical value, we fail to reject the null hypothesis. And lastly, we write the correct conclusion. One important variable to consider in trading stock is the daily volume. Volume is measured in number of shares traded in the stock. Stocks with lower volume tend to have more variability in the stock price. A stock analyst believes the median number of shares traded in stock A is greater than that in stock B. The analyst records the volume in millions of shares for each of the two stocks on the same day for 14 randomly selected trading days. The results are shown. At alpha equal to 0.05 level of significance, is there enough evidence to support the claim that the median volume of stock A is greater than that of stock B's? Use the Wilcoxon signed rank test. First, we have to calculate the differences, so we take x minus y, and we get 0.4, negative 1.3, negative 2.1, negative 3.2, 0.3, 0.7, 20.1, 1.3, 6.6, negative 0.8, 0.7, 5.1, negative 0.4, and 2.8. Then we take the absolute value, so this will remove any negative signs. Next, we need to sort the data from smallest to largest. So the smallest value is 0.3, then 0.4, 0.4, 0.7, 0.7, 0.8, 1.3, 1.3, 2.1, 2.8, 3.2, 5.1, 6.6, and 20.1. Then we need to assign a rank to the data. And for ties, we find the average. So 0.3 has rank 1. There's a tie for the second and third rank. So we have to take 2 plus 3 divided by 2 to get the average. And that's 2.5. So both 0.4 and 0.4 get a rank of 2.5. And there's a tie for the 4th and 5th position. So that average is 4.5. 0.8 is 6. The 1.3s, we have to take the average of the 7th and 8th rank. So they both get 7.5. Now there's no more ties, so the following ranks are just 9, 10, 11, 12, 13, and 14. To get the signed rank, we need to apply the original sign of the difference to the rank. So 0.3 was positive, so this will be a +1. 1.4 was negative, and the other 0.4 was positive. So we have a negative 2.5 and a positive 2.5. Both 0.7s were positive, so these are both plus 4.5. 0.8 was originally negative, so this is a negative 6. One of the 1.3s was negative, and the other was positive. So we have a negative 7.5 and a positive 7.5. The 2.1 was negative, so it's a negative 9. 2.8 was positive, so it's a plus 10. 3.2 was negative, so it's a negative 11. 5.1, 6.6, and 20.1 were all positive, so it's a plus 12, plus 13, and plus 14. The claim is that the first median is greater than the second median, and this is the alternative hypothesis. So this is a right-tailed test, and the null hypothesis says that the first median is less than or equal to the second median. Alpha is 0.05. N is the number of non-zero differences. And because none of the differences were 0, N is just 14. To find the critical value, let's look at the table. The critical value is going to be 25. To find T+, we add up the positive ranks and take the absolute value to get 69. To find T-, we add up the negative ranks and take the absolute value to get 36. Now, because this is a right-tailed test, T is equal to T-, so 36. So T is greater than the critical value, which means we fail to reject the null hypothesis. And the conclusion is, at the 0.05 level of significance, there is not enough evidence to support the claim that the medium volume of stock A is greater than that of stock B.